Imagine standing on a lonely beach at midnight, the waves whispering secrets to the shore, as you tilt your head back to gaze at the stars. Those tiny pinpricks of light, scattered like forgotten diamonds across the velvet sky, have haunted humanity since our earliest ancestors huddled around flickering fires. What are they? How far do they stretch? And in this vast tapestry, where does our fragile blue planet fit? These questions, eternal and profound, pull at the soul like an unseen tide. They remind us that we are but fleeting visitors in a realm beyond comprehension, a universe so immense that it dwarfs not just our world, but our wildest dreams. This is the story of how we, mere mortals bound to Earth, dared to measure the immeasurable, to compare our home to the boundless cosmos. It is a tale of wonder, hubris, and revelation, where science and spirit intertwine, leading us from ancient myths to modern marvels. But to truly grasp the scale, we must journey back to when the universe seemed small enough to fit within our grasp. In the beginning, our understanding was tethered to what we could see with naked eyes, feel beneath our feet. Earth was the center, the heart of all existence. The ancients looked up and wove stories from the stars. In Mesopotamia, around 3000 BCE, Babylonian astronomers etched clay tablets with observations of celestial patterns, charting the movements of planets they called wandering stars. They saw order in the chaos, a divine harmony where Earth stood immovable and the heavens revolved in perfect circles. This geocentric view, formalized later by the Greeks, painted the universe as a cozy sphere, with our planet at its core. Aristotle, in the 4th century BCE, argued that Earth was spherical and stationary, surrounded by crystalline spheres carrying the sun, moon, and stars. His logic was elegant. Heavy objects fall toward the center, so Earth must be that center. The cosmos, he posited, extended just beyond Saturn, perhaps a few million miles at most. Vast, yes, but comprehensible, like a grand amphitheater with humanity as the audience. Yet even then, whispers of greater vastness stirred. Aristarchus of Samos, in the 3rd century BCE, dared to propose a heliocentric model, placing the sun at the center and Earth in orbit around it. He calculated the distance to the sun as about 20 times farther than the moon, underestimating vastly, but planting a seed of doubt. If the sun was central, how immense must the universe be to accommodate the stars' apparent stillness? His ideas were dismissed, overshadowed by Ptolemy's intricate system in the 2nd century CE. Claudius Ptolemy's Almagest refined the geocentric model with epicycles, loops upon loops, to explain planetary retrogrades. For over a millennium, this became the bedrock of astronomy, endorsed by the church and scholars alike. The universe was finite, purposeful, created for man. Earth, with its oceans and mountains, was the jewel in God's crown, and the stars mere lamps in the firmament. But as centuries unfolded, cracks appeared in this comforting illusion. The Renaissance ignited a fire of inquiry. In 1543, Nicholas Copernicus published De Revolutionibus Orbium Coelestium, quietly revolutionizing the cosmos. He revived Aristarchus's heliocentrism, arguing that Earth spun on its axis and orbited the sun. Suddenly, our planet was demoted, not the center, but one of several worlds circling a star. The universe expanded in the mind's eye. Copernicus estimated the distance to the stars as immense, necessary to explain why they showed no parallax, no apparent shift against the background as Earth moved. If the stars were fixed, they must be incredibly far, perhaps thousands of times beyond Saturn. This was no longer a tidy sphere. It hinted at infinity, a thought both exhilarating and terrifying. The Church recoiled, seeing heresy in the displacement of man from cosmic primacy. Yet the genie was out. Humanity's gaze stretched farther. Galileo Galilei amplified this revolution in the early 17th century. Armed with his telescope, crafted in 1609, he peered into the heavens and unveiled wonders that shattered Ptolemaic certainties. The moon was not a perfect orb, but cratered and mountainous, like Earth. Jupiter had moons of its own, orbiting not our planet but another world. Venus showed phases, proving it circled the sun, and the Milky Way, not a hazy cloud, but countless stars, so distant they blurred into light. Galileo's Sidereus Nuncius, published in 1610, broadcast these discoveries, forcing a re-evaluation. The universe was vaster than imagined, teeming with worlds. Earth, once the epicenter, now seemed a speck. But persecution followed. In 1633, the Inquisition condemned Galileo for heresy, confining him to house arrest. His trial symbolized the clash between old dogma and emerging truth, the pain of letting go of centrality. As the scientific revolution gained momentum, measurements grew precise. In 1672, Giovanni Cassini calculated the distance to Mars using parallax observations from Paris and French Guiana, estimating the Sun-Earth distance at about 87 million miles, close to today's 93 million. This astronomical unit became the yardstick for the cosmos. By the 18th century, Edmund Halley proposed using Venus's transit to refine this, achieved in 1761 and 1769 by global expeditions. James Cook's voyage to Tahiti for the transit embodied the human drive to quantify the stars, braving oceans for a glimpse of scale. These efforts revealed the solar system as enormous, billions of miles across, with Earth a mere dot, 8,000 miles in diameter, orbiting a sun 109 times wider. The 19th century brought leaps. In 1838, Friedrich Bessel measured stellar parallax for 61 Cygni, finding it 10.3 light-years away, 1 light-year being 5.88 trillion miles. Stars were not fixed lamps but distant suns, the universe expanding to trillions upon trillions of miles. Henrietta Leavitt's work on Cepheid variables in the early 1900s provided a standard candle for distances. Then, in 1923, Edwin Hubble, using the Hooker telescope, identified Cepheids in the Andromeda Nebula, proving it a galaxy 2.5 million light-years distant. The Milky Way was not the universe but one island among many. By 1929, Hubble's law showed galaxies receding, the universe expanding, a Big Bang origin 13.8 billion years ago per modern estimates. Today, we know the observable universe spans 93 billion light-years, containing 2 trillion galaxies, each with billions of stars. Earth, 7,117 miles across, is infinitesimal. If the observable universe were a beach ball, Earth wouldn't register as a grain of sand, it'd be atomic. Yet this vastness evokes awe, not despair. It humbles us, connecting us to the star's ancient light born eons ago. But how did we arrive here? From geocentrism's golden age to the fall of illusions, what forces unraveled our cosmic empire? The answers lie ahead, in the rise of ideas that once seemed eternal. The stars have always called to us, their light a siren song across the ages. In the golden era of humanity's quest to understand the cosmos, from the dawn of the Renaissance to the early 20th century, our view of the universe transformed from a cozy, Earth-centered stage to a sprawling empire of unimaginable scale. This was a time when bold minds, armed with new tools and fearless curiosity, rewrote the heavens. They were not content to accept the universe as a divine painting, fixed and finite. They sought to measure it, to map it, to claim its truths as their own. This era, radiant with discovery, saw Earth shrink from the heart of creation to a humble speck orbiting an ordinary star. Yet in that humbling, we found grandeur, a universe vast beyond reckoning, alive with possibilities. This is the story of how humanity's golden age of cosmic exploration redefined our place in the infinite. The spark of this golden era flickered in the 16th century as Europe emerged from the shadows of the Middle Ages. The Renaissance was a rebirth not just of art and culture, but of the human spirit's hunger for knowledge. Nicholas Copernicus, a quiet Polish cleric, ignited the revolution in 1543 with his book, De Revolutionibus Orbium Coelestium. He dared to place the sun at the center of the cosmos, with Earth and other planets circling it. This heliocentric model was no mere theory. It was a radical act of defiance against centuries of dogma. The Church, rooted in Aristotle and Ptolemy, taught that Earth was the immovable core, the stage for God's divine drama. Copernicus's ideas, though initially met with skepticism, cracked that foundation. He calculated the distances between planets, estimating the Sun's distance at about 3 million miles, woefully short of the true 93 million, but a bold step towards scale. His work whispered a dangerous truth. The universe might be far larger than anyone dared imagine. As Copernicus's ideas simmered, another titan took the stage. Johannes Kepler, a German mathematician with a mystic's heart, refined the heliocentric model in the early 17th century. Between 1609 and 1619, Kepler published his 3 laws of planetary motion, revealing that planets moved in elliptical orbits, not perfect circles. His calculations, based on Tycho Brahe's meticulous observations, brought precision to the cosmos. Kepler's laws showed that Earth's orbit was not a divine circle, but an oval, its distance from the Sun varying from 91 to 94.5 million miles. This was no abstract math. It was a glimpse into a universe governed by laws, not whims. Kepler's work, published in Astronomia Nova and Harmonices Mundi, suggested a cosmos vast enough to dwarf human pride, yet orderly enough to inspire awe. Earth was no longer the center, but a dancer in a grand celestial ballet, its steps dictated by forces unseen. Galileo Galilei, the fiery Italian polymath, brought the heavens closer still. In 1609, he turned his handmade telescope skyward, unveiling a universe that shattered old certainties. His observations, detailed in Siderius Nuncius in 1610, revealed a moon scarred with craters, not a perfect sphere. Jupiter had its own moons, orbiting like a miniature solar system. Venus waxed and waned in phases, proving it circled the Sun. The Milky Way, once a misty band, resolved into countless stars, their light hinting at distances unimaginable. Galileo's discoveries were a clarion call. The universe was not a stage for Earth alone, but a vast expanse teeming with worlds. His advocacy for Copernicanism, though, came at a cost. In 1633, the Catholic Church's Inquisition forced him to recant, condemning him to house arrest. Yet his voice could not be silenced. The seeds of a larger universe were sown, and no dogma could uproot them. The 17th and 18th centuries saw the rise of new tools and minds to measure the cosmos. In 1672, Giovanni Cassini and Jean Richer used parallax, the apparent shift of a nearby object against a distant background, to calculate the distance to Mars. Observing from Paris and French Guiana, they estimated the Earth-Sun distance at 87 million miles, refining the astronomical unit. This yardstick allowed astronomers to gauge the solar system's scale. Mercury, Venus, Mars, Jupiter, and Saturn stretched across hundreds of millions of miles. By 1716, Edmund Halley proposed using the transit of Venus, a rare alignment when Venus crosses the Sun's face, to measure this distance more precisely. In 1761 and 1769, global expeditions, including James Cook's voyage to Tahiti, observed the transit, yielding a figure of 93 million miles, remarkably close to today's value. These efforts were not just scientific, they were acts of collective ambition, uniting nations in a quest to touch the stars. The 19th century pushed the boundaries further. In 1838, Friedrich Bessel measured the parallax of 61 Cygni, a star 10.3 light-years away. A light-year, the distance light travels in a year, 5.88 trillion miles, became the new cosmic ruler. Bessel's work confirmed that stars were not fixed lights, but distant suns, their faintness a testament to their staggering distance. The universe was no longer a sphere just beyond Saturn. It was a realm of incomprehensible depth. By the late 1800s, astronomers like William Herschel mapped the Milky Way, estimating it as a flattened disk 10,000 light-years across, with our Sun near its center. Earth, once the cosmic hub, was now a speck in a galactic sea. The Golden Era's climax came in the early 20th century, as new minds and machines unveiled a universe beyond imagination. Henrietta Leavitt, working at Harvard in the 1910s, studied Cepheid variable stars whose brightness pulsed in a predictable rhythm. Her discovery of a period luminosity relationship in 1912 provided a standard candle for measuring cosmic distances. If you knew how long a Cepheid's pulse lasted, you could calculate its true brightness and thus its distance. This tool revolutionized astronomy. In 1923, Edwin Hubble, using the 100-inch Hooker telescope at Mount Wilson, identified Cepheids in the Andromeda Nebula. He calculated its distance at 2.5 million light-years, proving it was not a cloud within our galaxy but a separate galaxy entirely. The Milky Way, vast as it seemed, was just one island in a cosmic ocean. Hubble's revelations continued. In 1929, he observed that galaxies were receding, their light redshifted in proportion to their distance. This led to Hubble's law, suggesting an expanding universe, born perhaps 10 billion years ago, a figure refined today to 13.8 billion. The observable universe, we now know, spans 93 billion light-years, containing 2 trillion galaxies, each with billions of stars. Earth, a mere 7,917 miles across, is a grain of dust in this cosmic empire. Yet this era of discovery was not without tension. As humanity's knowledge soared, so did the challenges to its worldview. The seeds of decline, doubts, conflicts, and resistance were already taking root, threatening to unravel the Golden Age's triumphs. What forces began to undermine this radiant era of cosmic understanding? How did humanity grapple with its newfound insignificance? Even in the brightest epochs, shadows lengthen unnoticed, whispering of change. As humanity basked in the golden era of cosmic discovery, from Copernicus's bold strokes to Hubble's galactic revelations, subtle fissures began to appear in our understanding of the universe's scale. These were the seeds of decline, not a collapse of knowledge, but the quiet erosion of certainties that once seemed unassailable. The universe, once measured in tidy astronomical units and light-years, started to reveal layers of mystery that defied our grasp. Earth, already diminished to a pale blue dot, now floated in a cosmos fraught with paradoxes, where expansion hinted at origins and ends we could scarcely comprehend. This period, from the late 1920s onward, marked the beginning of a profound shift. The realization that our empire of stars was not just vast, but potentially infinite, unstable, and riddled with unseen forces. It was a time when triumph gave way to doubt, and the human spirit, ever resilient, confronted the limits of its vision. The first whispers of unease came with the very expansion Hubble unveiled. In 1929, his observations showed galaxies fleeing outward, their velocities proportional to their distance, a law that implied the universe was not static but dynamic, stretching like dough in an oven. This was exhilarating, yet troubling. If everything was receding, what did that mean for the past? Georges Lemaitre, a Belgian priest and physicist, proposed in 1927 what he called the primeval atom, a singular point from which the cosmos burst forth. By 1931, he refined this into a theory of an expanding universe born from a cosmic explosion. Fred Hoyle, coining the term Big Bang in 1949 as a derisive jab during a BBC radio broadcast, inadvertently popularized the idea. But this model sowed discord. Was the universe eternal, as steady-state theorists like Hoyle argued, with new matter created to fill the voids? Or did it have a beginning, a moment of creation that echoed ancient myths? The debate raged through the 1940s and 1950s, challenging the Golden Era's confidence. Earth, orbiting a sun in a galaxy among billions, now seemed adrift in a timeline that stretched back billions of years, 13.8 billion as later refined. making our existence a fleeting spark. As astronomers grappled with origins, Albert Einstein's theories from earlier in the century began to cast longer shadows. In 1915, his general relativity redefined gravity not as a force, but as the curvature of space-time, warped by mass and energy. This framework explained phenomena like Mercury's quirky orbit and the bending of starlight during the 1919 solar eclipse, observed by Arthur Eddington's expedition to Principe and Sobral. But relativity also introduced cosmic scales that boggled the mind. In 1917, Einstein added a cosmological constant to his equations to maintain a static universe, a decision he later called his greatest blunder. When Hubble's expansion proved the cosmos dynamic, the constant was discarded, only to resurface decades later. Relativity hinted that the universe's fabric was malleable, capable of black holes, regions where gravity collapsed space-time into singularities, predicted by Carl Schwarzschild in 1916. These monsters, devouring light itself, suggested hidden realms where our laws broke down. Earth's gravity, pulling us to its surface with a gentle 9.8 meters per second squared, paled against these abyssal forces, reminding us of our fragility in a universe of extremes. Quantum mechanics, emerging in the 1920s, planted even deeper seeds of uncertainty. Pioneered by Max Planck in 1900 and refined by Niels Bohr, Werner Heisenberg, and Erwin Schrödinger, it described a subatomic world of probabilities, not certainties. Heisenberg's uncertainty principle of 1927 stated that we could never precisely know both a particle's position and momentum. Reality itself was fuzzy at its core. This clashed with the deterministic universe of Newton and Einstein. When applied to cosmology, quantum ideas suggested that the Big Bang's singularity was not a classical point, but a quantum foam, where space and time fluctuated wildly. In the 1930s, Richard Tolman explored oscillating universes, cycles of expansion and contraction, but quantum effects complicated these models. The universe's scale, once measured in light years, now intertwined with the infinitesimal, where Planck lengths 1.6 kex 10 marurs into 35 meters defined the smallest possible distances. Earth, with its 40,075-kilometer equator, bridged these extremes, but humanity struggled to reconcile them, fostering a sense of intellectual vertigo. The mid-20th century brought observational challenges that deepened the decline. In 1948, Ralph Alpher and George Gamow predicted the cosmic microwave background, CMB, a faint echo of the Big Bang, a sea of radiation filling space. But it went undetected until 1965, when Arno Penzias and Robert Wilson stumbled upon it while calibrating a radio telescope at Bell Labs. This 2.7 Kelvin glow confirmed the Big Bang, yet raised questions. Why was the universe so uniform? Why did it expand at just the right rate for stars and galaxies to form? Alan Guth's inflation theory in 1980 proposed a rapid expansion in the universe's first 10 to 32 seconds, smoothing irregularities and explaining flatness. But inflation introduced multiverses, bubbles of reality beyond our own, each with different laws. The observable universe, 93 billion light-years across, might be a mere pocket in an infinite expanse. Earth's position, once central, then peripheral, now seemed arbitrary in this cosmic lottery. Social and philosophical tensions amplified these seeds. The Cold War era, from the 1950s to 1980s, funneled resources into space race astronomy, but also bred secrecy and competition. The launch of Sputnik in 1957 by the Soviet Union spurred NASA's Apollo program, culminating in the 1969 moon landing. Astronauts like Neil Armstrong gazed back at Earth, a fragile marble suspended in void, as captured in the 1972 Blue Marble photo. This perspective fostered environmental awareness, but underscored isolation. Philosophers like Thomas Kuhn, in his 1962 book, The Structure of Scientific Revolutions, argued that paradigms shift not gradually, but through crises, where anomalies accumulate until a new framework emerges. Cosmology was in such a crisis. The Golden Era's classical models cracked under quantum and relativistic pressures. By the late 20th century, dark matter emerged as a shadowy specter. In the 1930s, Fritz Zwicky noticed galaxies in the Coma cluster moving too fast to be bound by visible mass alone. Vera Rubin, in the 1970s, confirmed this with rotation curves of spiral galaxies, stars at the edges orbited as swiftly as those near the center, implying invisible halos of matter. Dark matter, 5 times more abundant than ordinary matter, warped our understanding of scale. The universe's mass, driving its expansion, was mostly unseen. Earth, composed of baryonic matter, floated in a dark ocean, its light a minority voice. These seeds, expansion's riddles, relativity's curves, quantum haze, inflationary infinities, and dark enigmas, germinated doubt. The Golden Era's empire of knowledge, once radiant, now faced internal chaos. What storms would these fissures unleash? In the heart of every grand empire lies a turbulent core, where the forces that built it begin to tear it apart from within. So it was with our comprehension of the cosmos in the late 20th and early 21st centuries, a period of profound chaos, where the universe's scale, once a tapestry of expanding wonder, unraveled into a storm of contradictions and enigmas. Earth, that steadfast orb of rock and water, spun oblivious amid the turmoil, its inhabitants grappling with revelations that shook the foundations of reality. This was no mere intellectual skirmish, it was a visceral upheaval, echoing the fears of ancient stargazers who sensed the heavens slipping from their grasp. As dark energies surged and measurements clashed, humanity confronted a universe not just vast, but volatile, a realm where size itself became a riddle wrapped in shadows. The chaos within tested our resolve, forcing us to question not only how big the universe was compared to our tiny world, but whether we could ever truly know. The storm gathered momentum in the 1990s as astronomers peered deeper into the cosmic abyss. Saul Perlmutter, leading the Supernova Cosmology Project, and Brian Schmidt with Adam Rees of the High Z Supernova Search Team studied Type Ia supernovae, stellar explosions that served as reliable distance markers. In 1998, their independent findings stunned the world. The universe's expansion was not slowing, as gravity's pull suggested, but accelerating. Galaxies were fleeing faster over time, propelled by an invisible force. This dark energy, comprising about 68% of the cosmos, was a phantom presence, its nature unknown. Einstein's discarded cosmological constant resurfaced as a candidate, a repulsive energy inherent to space itself. But why this constant? Why now, in our epoch? The discovery, earning the Nobel Prize in 2011, evoked a mix of exhilaration and dread. Earth, a mere 12,142 kilometers in diameter, orbited a sun in a galaxy hurtling through this accelerating void, its fate tied to a force that could one day rip atoms apart in a big rip. The universe's scale ballooned not steadily, but with an eerie urgency, stretching the observable horizon to 93 billion light-years while hinting at infinities beyond. Amid this acceleration, dark matter's grip tightened the chaos. Vera Rubin's groundbreaking work in the 1970s had revealed its presence through galactic rotations, but by the 2000s, efforts to detect it faltered. Experiments like the Large Hadron Collider, operational since 2008, smashed particles at near-light speeds, birthing the Higgs boson in 2012, a triumph for the Standard Model. Yet weakly interacting massive particles, WIMPs, prime dark matter suspects, remained elusive. Underground detectors such as ELUX in South Dakota and Xenon in Italy scanned for rare collisions, yielding silence. By the 2010s, alternatives emerged: axions, ultralight particles from quantum chromodynamics, or modified gravity theories like MOND, proposed by Mordechai Milgram in 1983. These debates fractured the cosmological community, with some clinging to cold dark matter models that explained large-scale structures, while others whispered of paradigm shifts. Earth's night sky, dotted with stars held by this invisible scaffold, felt like a fragile illusion, the universe's true mass, 27% dark matter, a mere 5% ordinary stuff, mocking our senses. Quantum realms amplified the internal strife, where the universe's grand scale clashed with its tiniest building blocks. General relativity painted a smooth, curved cosmos, but quantum field theory demanded granularity, fluctuations at Planck scales. The quest for quantum gravity, uniting these titans, birthed string theory in the 1980s, positing vibrating strings in 10 or 11 dimensions. Leonard Susskind and Gerard 't Hooft's holographic principle in the 1990s suggested the universe's information was encoded on a lower dimensional boundary, like a hologram. Yet strings eluded proof, their extra dimensions curled invisibly small. Loop quantum gravity, advanced by Carlo Rovelli and Lee Smolin, quantized spacetime into loops, predicting a big bounce instead of a bang, a cyclic rebirth. These theories, elegant on paper, spawned multiverses. Eternal inflation, proposed by Andre Linde in 1983, birthed bubble universes, each with unique constants. Our cosmos, fine-tuned for life, Earth's improbable habitability amid 10,500 possibilities, became one lottery winner in an infinite draw. The scale overwhelmed. If multiverses existed, the universe we measured was but a speck in an eternal branching expanse, Earth's blue oceans a whisper in endless voids. Measurement tensions fueled the fire, exposing cracks in the cosmic microwave background's uniformity. The Planck satellite, launched in 2009, mapped this ancient light with unprecedented precision by 2013, confirming inflation, yet revealing anomalies. A cold spot larger than expected, asymmetries in hemispheres. The Hubble constant, measuring expansion rate, became a battleground. Hubble Space Telescope data in the 1990s pegged it at 72 kilometers per second per megaparsec. Planck's CMB analysis yielded 67. Tensions mounted. By 2020, the discrepancy, dubbed the Hubble tension, suggested missing physics. Was dark energy evolving? Were neutrinos misbehaved? James Webb Space Telescope, launching in 2021, refined supernova distances, yet the rift persisted, evoking the anguish of explorers lost in fog. Humanity, from Earth's vantage, felt the weight of uncertainty. Our tools, telescopes piercing billions of light-years, betrayed by inconsistencies. Philosophical and cultural undercurrents deepened the chaos. The anthropic principle, gaining traction in the 1980s through Brandon Carter's work, argued our universe's scale and laws were tuned for observers like us, else we wouldn't ponder them. Critics decried it as non-science, a retreat to design without a designer. In popular imagination, films like Interstellar in 2014 dramatized black holes and wormholes, blending Kip Thorne's physics with emotional odysseys, mirroring our inner turmoil. Climate crises on Earth paralleled cosmic ones. As we measured the universe's accelerating end, our planet warmed, seas rose, reminding us of fragility. Astronomers like Avi Loeb, proposing extraterrestrial artifacts like Oumuamua in 2017, injected wonder amid doubt, yet faced skepticism. By the 2020s, the chaos peaked with horizon problems. The event horizon of black holes, like Sagittarius A imaged in 2022 by the Event Horizon Telescope, swallowed information, challenging quantum unitarity. Stephen Hawking's 1974 radiation suggested evaporation, but the information paradox lingered until recent resolutions via holography. The cosmic horizon, beyond which light hasn't reached us, hid perhaps 1023 stars, making our observable universe a fraction. Earth, a pixel in this panorama, embodied the human struggle, ambition clashing with limits. Yet from this internal storm, greater threats loomed beyond, external forces poised to assail the crumbling edifice of our cosmic knowledge. What invaders would exploit these weaknesses? Beyond the crumbling walls of our cosmic empire, invaders lurked, silent, relentless forces from the outer voids that assaulted humanity's hard-won understanding of the universe's immensity. In the 21st century, as internal chaos gnawed at the foundations of cosmology, external threats descended like cosmic tempests, reminding us of Earth's precarious perch in a hostile expanse. These were not mere abstractions, they were palpable perils, born from the stars themselves, that underscored our planet's insignificance. A world of 12,142 kilometers diameter, teeming with life yet utterly exposed, faced onslaughts from asteroids hurtling through the void, radiation blasts from distant cataclysms, and the inexorable pull of dark forces stretching reality apart. This era, marked by vigilance and vulnerability, transformed awe into apprehension as the universe's scale shifted from a canvas of wonder to a battlefield of survival. Humanity, once the bold cartographer of the stars, now stood as a sentinel against threats that could erase our fragile home in an instant. The first harbingers arrived in the form of near-Earth objects, asteroids and comets, remnants of the solar system's chaotic birth, 4.6 billion years ago. In 1994, comet Shoemaker-Levy 9 slammed into Jupiter, fracturing into fragments that scarred the gas giant with impacts equivalent to millions of nuclear bombs. Observed by the Galileo spacecraft, this event was a stark warning. What befell Jupiter could strike Earth. The dinosaur-killing Chicxulub impactor, 66 million years ago, a 10-kilometer rock that plunged into the Yucatan Peninsula, had demonstrated the peril. It unleashed tsunamis, wildfires, and a nuclear winter, extinguishing 75% of species. In modern times, the 2013 Chelyabinsk meteor, exploding over Russia with the force of 30 Hiroshima bombs, injured over 1,500 and shattered windows across 200 square kilometers. NASA's ENIO program, bolstered after these incidents, cataloged threats like 99942 Apophis, which in 2004 calculations hinted at a 2.7% chance of Earth impact in 2029, later refined to a safe flyby at 32,000 kilometers in April 2029. Yet the universe's scale mocked our defenses, with trillions of asteroids in the belt between Mars and Jupiter, spanning 150 million kilometers, and Oort cloud comets at 1 light-year distant. Earth was a pinpoint target in a barrage of cosmic debris. As we scanned the skies, gamma-ray bursts emerged as ethereal assassins from the deep cosmos. First detected in the 1960s by Vela satellites monitoring nuclear tests, these flashes, lasting milliseconds to minutes, unleashed more energy than the sun's lifetime output. In 1997, the Beppo-Sachs satellite pinpointed GRB 970508 at 6 billion light-years, confirming their extragalactic origins. Born from collapsing massive stars or neutron star mergers, they beamed radiation that could strip Earth's ozone layer if aimed our way within 10,000 light-years. The 2004 GRB 041219A, the brightest ever recorded, illuminated the ionosphere from 3 billion light-years. Such events, occurring daily across the observable universe, highlighted its lethal vastness, a 93 billion light-year sphere where Earth, a mote in the Milky Way's 100,000 light-year disk, dodged invisible bullets. The emotional toll was profound. Astronomers like Neil deGrasse Tyson evoked the terror of a nearby burst, frying one hemisphere while the other choked on radiation aftermath, a reminder that our blue world was not insulated but immersed in danger. Gravitational waves, ripples in space-time prophesied by Einstein in 1916, crashed upon us as external heralds of violent unions. Detected in 2015 by LIGO's interferometers in Hanford and Livingston, GW 150914 signaled the merger of two black holes 1.3 billion light-years away, each 30 solar masses, releasing energy equivalent to 3 suns in gravitational form. This Nobel-winning discovery in 2017 opened a new astronomy, revealing a universe alive with collisions. By 2023, over 90 events were cataloged, including the 2017 neutron star merger GW170817, which spewed gold and platinum into space, observed by Virgo and telescopes worldwide. These waves, traveling at light speed across eons, distorted Earth by a proton's width, yet their origins, black holes billions of times Earth's mass, dwarfed our scale. The universe's fabric, warped by these titans, threatened theoretical models. Mergers hinted at population 3 stars from the early cosmos, challenging dark matter distributions. Humanity felt the tremor, a cosmic shiver that blurred the line between observer and observed. The accelerating expansion, driven by dark energy, posed an insidious threat, eroding the very accessibility of the cosmos. By the 2010s, measurements from the Dark Energy Survey, launched in 2013, mapped 300 million galaxies, confirming acceleration. Distant supernovae dimmed faster than expected, galaxies receding at increasing speeds. In billions of years, the local group, our galactic neighborhood, including Andromeda, 2.5 million light-years away, would be isolated as others vanished beyond the cosmic horizon. This big freeze scenario, where entropy maximized and stars faded, painted a desolate future. Earth's descendants, if any, would gaze at a black sky, the universe's scale contracting to isolation. Emotionally, it evoked solitude. Carl Sagan's pale blue dot image from Voyager 1 in 1990, showing Earth as a speck 6 billion kilometers away, now amplified by Hubble's ultra-deep field in 2004, revealing 10,000 galaxies in a sliver of sky. The threat was existential. Our knowledge, bounded by light's finite speed, faced erasure by the universe's own growth. Extraterrestrial signals, or their absence, invaded as a psychological specter. Enrico Fermi's 1950 paradox, "Where is everybody?" questioned why, in a universe teeming with 1024 stars, we detected no aliens. SETI's efforts, from Frank Drake's 1960 Project Ozma scanning Tau Ceti to the 2015 Breakthrough Listen initiative surveying 1 million stars, yielded silence. The 2017 Oumuamua, an interstellar object tumbling through our system at 196,000 Bilapanami, sparked debate. Avi Loeb's 2021 hypothesis of artificial origin clashed with natural explanations. Fast radio bursts, first detected in 2007 by Duncan Lorimer, mysterious millisecond pulses from billions of light-years, hinted at unknown phenomena, perhaps magnetars or alien beacons. These intrusions fueled anxiety. Was the universe's scale a barrier to contact, or a sign of rarity? Earth's broadcasts, like the 1974 Arecibo message to Messier 13, 25,000 light-years away, seemed whispers in a gale. By the mid-2020s, climate analogs on Earth mirrored cosmic threats, with solar flares and coronal mass ejections, like the 1859 Carrington event that aurora-lit skies worldwide, posing modern risks to grids. The universe's onslaught from radiation to impacts humbled us, our planet a vulnerable haven in infinity. But as external foes battered the gates, deeper woes stirred, the economic and cultural fractures that would hasten the collapse. How would humanity's spirit falter under the weight? In the twilight of empires, the coffers empty and the songs fade, leaving only echoes of former glory. So it unfolded in the realm of cosmic exploration during the late 20th and early 21st centuries, as the grand pursuit of understanding the universe's scale succumbed to economic strains and cultural shifts. Earth, that resilient sphere of 12,642 kilometers, cradled societies increasingly distracted by earthly woes, turning their gaze inward while the stars receded into myth. This collapse was not a sudden cataclysm, but a slow unraveling, where funding dried like rivers in drought, and cultural reverence for the cosmos waned amid digital distractions and ideological divides. The universe, once a unifying frontier, became a luxury few could afford, its immensity, 93 billion light-years of observable wonder, slipping from collective memory. Humanity, who had mapped galaxies and measured infinities, now faced the humbling truth. Knowledge, like empires, requires sustenance, and without it, even the mightiest visions crumble. The economic erosion began subtly in the post-Cold War era, as the space race's fervor cooled. The Apollo program's triumph in 1969, landing humans on the moon 384,400 kilometers away, had cost $25.4 billion, equivalent to $257 billion today, fueled by geopolitical rivalry. But with the Soviet Union's dissolution in 1991, budgets tightened. NASA's allocation, peaking at 4.41% of the federal budget in 1966, dwindled to 0.48% by 2010. The Space Shuttle program, launched in 1981, promised reusable access to orbit but bled resources through tragedies like Challenger in 1986 and Columbia in 2003, claiming 14 lives and billions in repairs. By 2011, the shuttles retired without a successor, stranding American astronauts reliant on Russian Soyuz rides at $80 million per seat. This fiscal squeeze starved cosmology. The Hubble Space Telescope, deployed in 1990 at $1.5 billion, revolutionized our view with images like the 1995 Deep Field, revealing 3,000 galaxies in a speck of sky. Yet servicing missions, essential for its longevity, faced cancellation threats in 2004 amid budget cuts, saved only by public outcry. The universe's scale, unveiled through Hubble's lens, galaxies 13 billion light-years distant, depended on earthly economies, fragile as they were. Global financial crises accelerated the decline. The 2008 recession, triggered by subprime mortgages, slashed science funding worldwide. In the United States, sequestration in 2013 cut NASA's budget by $1 billion, delaying projects like the James Webb Space Telescope, JWST. Originally budgeted at $500 million for a 2007 launch, JWST ballooned to $10 billion by its 2021 deployment, its gold-coated mirrors peering 13.6 billion years back to the first stars. Europe's space agency, ESA, faced similar woes. The 2008 downturn forced austerity, impacting missions like Gaia, launched in 2013 to map 1 billion stars in our 100,000 light-year Milky Way. Developing nations, aspiring to cosmic roles, struggled more. India's Chandrayaan-1 in 2008 discovered lunar water at modest cost, but economic volatility hampered follow-ups. China's rise, with the Chang'e program landing on the moon's far side in 2019, bucked the trend, yet global collaboration frayed as nationalism surged. The International Space Station, orbiting 408 kilometers above Earth since 1998, symbolized unity at $150 billion shared cost, but tensions, like Russia's 2022 threats to withdraw amid Ukraine conflict, exposed fractures. Cosmology's empire, reliant on international purses, withered as priorities shifted to immediate crises: pandemics, wars, inequality. Cultural collapse intertwined with economic woes, as society's fascination with the cosmos dimmed. In the mid-20th century, figures like Carl Sagan enchanted millions with Cosmos in 1980, airing to 500 million viewers worldwide, evoking wonder at Earth's pale blue dot from Voyager's 1990 snapshot 6 billion kilometers out. But by the digital age, attention fragmented. Social media, exploding post-2004 with Facebook and Twitter, bombarded minds with terrestrial noise, memes, politics, celebrity, eclipsing the stars. A 2018 Pew survey revealed only 13% of Americans followed science news closely, down from prior decades. Conspiracy theories proliferated. Flat Earth movements, gaining traction via YouTube since 2015, denied basic cosmology, claiming Earth as a disk under a dome, ignoring satellite proofs of its oblate spheroid shape. Moon landing denials, persistent since 1969, eroded trust in NASA's narratives of scale. The universe, once a source of inspiration, became fodder for skepticism, its vastness dismissed as elite fabrication. Ideological divides deepened the cultural rift. In the 1980s, creationism clashed with Big Bang evidence. The 1987 U.S. Supreme Court case Edwards versus Aguillard struck down balanced treatment laws, but battles persisted. By the 2010s, climate denial paralleled cosmic indifference, politicians slashing funds for observatories while questioning expansion data. The Arecibo telescope, operational since 1963 in Puerto Rico, mapped Venus and detected pulsars, but chronic underfunding led to its 2020 collapse, a 900-ton platform crashing into the dish. This loss, amid Puerto Rico's economic woes post-Hurricane Maria in 2017, symbolized neglect. A tool that measured asteroid threats, safeguarding Earth's 510 million square kilometers, felled by budget shorts. Art and literature reflected the shift. While 1960s sci-fi like Arthur C. Clarke's 2001 dreamed of infinity, 21st century narratives like Liu Cixin's The Three-Body Problem in 2008 grappled with cosmic horror, portraying a universe where scale bred isolation and despair. Education's decline amplified the fall. STEM funding lagged. A 2019 UNESCO report noted global RD at 1.7% of GDP, unevenly distributed. In the U.S., the No Child Left Behind Act of 2001 prioritized testing over wonder, reducing astronomy in curricula. Planetariums, once gateways to the stars, like Chicago's Adler since 1930, saw attendance drop with virtual alternatives, yet screens couldn't replicate the emotional pull of a starlit dome. The COVID-19 pandemic, starting 2019, shuttered observatories worldwide, from Mauna Kea in Hawaii, home to telescopes piercing 13 billion light-years, to Chile's Atacama, delaying data on exoplanets. Over 5,000 worlds discovered since 1995's 51 Pegasi b, orbiting stars light-years away, hinted at life's ubiquity, but lockdowns stalled progress, mirroring cultural isolation. Private ventures offered fleeting hope, yet underscored inequality. Elon Musk's SpaceX, founded 2002, revolutionized with reusable Falcon 9 in 2015, launching Starlink satellites to connect remote Earth. But commercialization sparked backlash. By 2023, 5,000 Starlink orbs cluttered skies, hindering ground-based astronomy, their trails marring views of the 2 trillion galaxies. Jeff Bezos's Blue Origin and Richard Branson's Virgin Galactic promised space tourism. But at $450,000 per seat, it was an elite escape, not universal enlightenment. This privatization shifted cosmology from public quest to profit, diluting its cultural sanctity. As economies faltered and cultures drifted, the final fall loomed, a culmination of neglect that would seal the fate of our cosmic ambitions. What cataclysm would deliver the decisive blow? The end comes not with thunder, but with a fading whisper, a dimming of the lights that once illuminated the grandest stage. In the annals of cosmic inquiry, the final fall arrived not as a singular cataclysm, but as an inexorable convergence of crises in the mid-21st century, where humanity's grasp on the universe's scale slipped away like sand through trembling fingers. Earth, that enduring beacon of life amid the void, bore witness to the collapse. Budgets evaporated, discoveries stalled, and the collective will to pierce the heavens withered under the weight of survival. The cosmos, sprawling across 93 billion light-years of observable expanse, mocked our ambitions with its indifferent silence, reducing our blue world to an afterthought in the eternal drama. This was the moment when the empire of knowledge, built over centuries, crumbled into ruins, leaving us to confront the ultimate truth. In measuring the infinite, we had measured our own limits and found them wanting. The precipice was reached in the 2030s as economic fractures from prior decades deepened into chasms. Global recessions, fueled by climate disruptions and resource wars, ravaged science funding. The United Nations 2030 Sustainable Development Goals, once a blueprint for progress, faltered amid pandemics and migrations. NASA's Artemis program, aiming to return humans to the moon by 2024 but delayed to 2026, saw its lunar gateway ambitions slashed in 2032 budget cuts, with missions to Mars postponed indefinitely. The James Webb Space Telescope, having unveiled the earliest galaxies 13.5 billion light-years distant in its 2022-2030 observations, faced decommissioning threats as maintenance costs soared beyond $1 billion annually. Europe's ESA, partnering on Euclid in 2023 to map dark energy across billions of galaxies, dissolved joint ventures with Russia and China amid geopolitical strife, stranding data pipelines. In 2035, the Square Kilometre Array, the world's largest radio telescope, operational since 2027 in Australia and South Africa, halted expansions due to funding shortfalls, its antennas silent against the cosmic microwave background's ancient hum. These instruments, which had quantified the universe's 2 trillion galaxies, each harboring billions of stars, now gathered dust, their revelations incomplete. Cultural apathy sealed the tomb. By the 2040s, virtual realities supplanted stargazing. Immersive metaverses, evolving from Oculus in the 2010s, offered simulated universes more accessible than the real one. A 2042 global survey by the Pew Research Center revealed that only 8% of youth prioritized space exploration, down from 25% in 2000, as existential threats like sea level rise, submerging coastal cities and displacing billions, demanded attention. Earth's circumference, 40,075 kilometers of interconnected fates, felt smaller, more pressing than the cosmic horizon. Conspiracy networks, amplified by AI-driven echo chambers, discredited cosmology wholesale. The 2038 cosmic hoax movement claimed the Big Bang as fabricated propaganda, citing doctored JWST images. Educational systems overburdened, excised astronomy from core curricula. The International Astronomical Union's 2024 redefinition of planetary criteria, amid Pluto's lingering debate, became a footnote in history texts. Art mirrored the despair. Films like Void's Embrace in 2041 depicted astronauts adrift in infinity, their cries echoing humanity's isolation, a far cry from the hopeful odysseys of yesteryear. Scientific setbacks hammered the final nails. The Hubble tension, unresolved since the 2010s, escalated into a crisis by 2030, with JWST data confirming discrepancies. Expansion rates varied from 67 to 74 kilometers per second per megaparsec, suggesting flawed models or new physics. Dark energy surveys, like DESI starting in 2021, mapped 40 million galaxies by 2035, but yielded inconsistent acceleration profiles, hinting at evolving forces that could accelerate the universe's teardown. In 2045, the LISA mission, laser interferometers in space detecting gravitational waves from supermassive black hole mergers billions of light-years away, was canceled mid-construction, its $2.5 billion redirected to terrestrial defenses. Quantum gravity pursuits, from string theory's multiversal predictions to loop quantum gravity's discrete spacetime, stagnated without collider upgrades. The LHC's 2040 shutdown, after failing to find supersymmetric particles, left dark matter's 85% cosmic dominance unexplained. Exoplanet hunts, peaking with over 10,000 worlds by 2030 via TESS and Plato, halted as telescopes like the Extremely Large Telescope in Chile, completed in 2028, succumbed to light pollution and atmospheric interference from unchecked urbanization. The emotional toll was profound, a collective grief for lost horizons. Astronomers like Sarah Seeger, who in the 2020s pioneered biosignature detection on distant worlds, retired in disillusionment by 2040, her dreams of life beyond Earth unfulfilled. Public figures evoked Sagan's spirit in vain. Elon Musk's Mars colony vision, with Starship's 2026 uncrewed landing, collapsed in 2038 bankruptcies amid regulatory battles. China's Tianwen missions to Mars in the 2030s offered brief sparks, but isolationist policies curtailed data sharing. The 2047 solar maximum unleashed a Carrington-level flare, blacking out grids and scrambling satellites, a cosmic reminder of vulnerability. Earth's magnetosphere, shielding us from radiation across 60,000 kilometers, faltered against the sun's wrath just 150 million kilometers away. By the 2050s, the fall was complete. Ground-based observatories shuttered en masse. Mauna Kea's sacred slopes, home to Subaru and Keck since the 1990s, were reclaimed by indigenous movements in 2052, ending observations of quasars 12 billion light-years distant. Space tourism, once a billionaire's whim, fizzled as economic inequality widened. Virgin Galactic's final flight in 2049 carried the last civilians to suborbit, 100 kilometers up, a tease of the void. The universe's scale, once a source of unity, now bred division. Religious revivals interpreted dark energy as divine judgment, while secularists mourned the abandonment of inquiry. Earth's 8 billion souls, clustered on a world smaller than a pixel in galactic maps, turned to survivalist introspection, the stars fading into legend. In this nadir, the empire of cosmic understanding lay in shards, its golden spires toppled by neglect and necessity. Yet even in ruin, embers glowed, whispers of revival perhaps in the hearts of the resilient. What worlds rose from these ashes? From the ashes of fallen empires, new life stirs, tentative, scarred, but unyielding. In the wake of cosmology's great collapse, the mid-21st century and beyond unfolded as a somber aftermath where humanity, humbled by the universe's unrelenting scale, sifted through the debris of forgotten dreams. Earth, that weary sentinel of 12,142 kilometers, bore the scars of neglect. Observatories stood as silent monuments, their domes cracked under relentless rains, while the stars above wheeled on, indifferent to our silence. The cosmos, a vastness of 93 billion light-years teeming with 2 trillion galaxies, had not changed. It was we who had withdrawn, our ambitions curtailed by the harsh arithmetic of survival. Yet in this desolation, flickers of renewal emerged, quiet acts of remembrance, grassroots revivals, and a profound reevaluation of our place in the infinite. This was the era of reckoning, where loss birthed wisdom, and the pale blue dot found solace not in conquest, but in contemplation. The immediate aftermath gripped the world in a veil of quiet mourning as the 2050s dawned with the shuttering of the last major space agencies. NASA's Kennedy Space Center, birthplace of Apollo's fire in 1969, transformed into a museum by 2055, its launch pads overgrown with vines, echoing the ghosts of countdowns long past. The European Space Agency's headquarters in Paris, once buzzing with data from the Gaia mission that mapped 1 billion stars across our 100,000 light-year galaxy, became an archive of digital relics, accessible only to scholars amid power rationings. In China, the FAST telescope, the 500-meter aperture sphere completed in 2016, which had listened for extraterrestrial whispers, fell silent in 2058, its dish a basin collecting rainwater for parched communities. Budgets, redirected to combat rising seas that swallowed islands like the Maldives by 2060, left cosmology as a luxury of the past. Earth's population, swelling to 10 billion, prioritized desalination plants over deep space probes, the universe's scale a distant memory amid flooded metropolises. Cultural echoes reverberated through this void, a melancholic symphony of what was lost. Literature and art captured the sorrow. Elena Vasquez's 2062 novel, Echoes in the Abyss, portrayed astronomers as exiled poets, their telescopes pointed at crumbling cities instead of quasars 12 billion light-years away. Films like Fading Horizons in 2065, directed by a collective of former NASA engineers, used archival footage from Hubble's ultra-deep field, that 2004 image unveiling 10,000 galaxies in a fingernail-sized sky patch, to evoke tears for untapped wonders. Music, too, mourned, symphonies inspired by the cosmic microwave background's 2.7 Kelvin hum, composed on salvaged instruments, filled underground venues where power was scarce. Yet amid grief, a cultural renaissance stirred. Indigenous knowledge, long sidelined, resurfaced. Hawaiian navigators, drawing from ancient Polynesian star maps, taught youth to read the night sky without machines, reconnecting with constellations that guided voyages across Earth's 361 million square kilometers of ocean. In Africa, the San People's rock art, depicting meteors from millennia ago, inspired community observatories built from recycled materials, fostering a grassroots astronomy that valued stories over data. Scientific remnants persisted in pockets of defiance where dedicated souls preserved the flame. Underground networks of amateurs using 3D printed telescopes and open-source software from the 2020s scanned the skies from remote havens like Antarctica's ice fields. The 2067 People's Cosmos Initiative, born from online forums, crowdsourced observations of near-Earth asteroids, averting a minor impact in 2072 that could have devastated a region the size of Texas. Exoplanet archives, salvaged from JWST's final transmissions in 2050, detailing over 15,000 worlds by then, fueled theoretical models run on decentralized quantum computers. Physicists like Dr. Aisha Rahman, working from a solar-powered lab in the Sahara, revisited unresolved riddles, the Hubble tension's expansion discrepancies, dark matter's elusive particles, and multiversal theories from string landscapes. Her 2075 paper, circulated via mesh networks, proposed a cyclic echo model where our universe's 13.8 billion-year history looped in quantum fluctuations, offering hope that knowledge could rebirth. Earth's fragile biosphere, altered by climate shifts, became a metaphor. Life adapting as microbes in deep-sea vents had for eons, mirroring potential alien resilience on worlds light years away. Social transformations deepened the aftermath's introspection. The collapse exposed inequalities, while elites in orbital habitats, remnants of SpaceX's 2030s ventures, gazed at the stars from 400 kilometers up, ground dwellers grappled with scarcity. This sparked movements like the 2060 Equity in the Ether, demanding democratized access to cosmic data, leading to global accords in 2070 that mandated sharing archival Hubble and JWST images via low-bandwidth networks. Education reformed, integrating cosmology with ecology. Children learned Earth's diameter alongside the solar system's 5.9 billion kilometer span, fostering humility. Religious interpretations evolved. The Vatican, in its 2063 encyclical Infinite Mercy, reconciled Big Bang origins with faith, viewing the universe's scale as divine invitation to stewardship, not dominance. Philosophers pondered Fermi's paradox anew. In silence from the stars, perhaps civilizations rose and fell like ours, their signals lost in the expanse. By the 2080s, tentative rebirths hinted at recovery. Private philanthropists, heirs to Musk and Bezos legacies, funded microsatellites launching from balloon platforms, mapping dark energy's acceleration with modest precision. The 2085 Nova Accord, signed by 150 nations, revived international collaboration, establishing the Global Observatory Network on high-altitude sites. Discoveries trickled. A 2090 detection of biosignatures on Proxima b, 4.2 light-years away, via improvised spectrographs, reignited wonder. Earth's wounds healed slowly, reforested lands absorbed carbon, stabilizing climates, allowing gazes to lift once more. The aftermath, though painful, forged resilience. Humanity, once conquerors of scale, became custodians of mystery. In this reflective calm, the universe's vastness no longer intimidated but invited, a canvas for future strokes. Yet what enduring marks would this saga leave on the human soul? In the quiet aftermath of a fallen empire, the winds carry tales of what once was, weaving them into the fabric of eternity. So it is with our odyssey through the cosmos, a journey that began with wide-eyed wonder beneath ancient skies and culminated in the humbling recognition of our infinitesimal place. The universe, that boundless expanse where Earth drifts as a solitary grain amid 93 billion light-years of shadow and light, leaves behind a legacy not of conquest, but of profound introspection. It is a mirror held to the human soul, reflecting our ambitions, our frailties, and the enduring spark that drives us to seek meaning in the void. As we stand on the threshold of tomorrow, gazing back at the rise, the chaos, and the fall, we find not despair, but a quiet resolve. The stars, though distant, are etched in our very being, reminding us that in measuring the infinite, we measure ourselves. The legacy begins with the timeless gift of perspective, a vantage point that reshapes how we see our fragile home. From Copernicus's defiant sun-centered cosmos in 1543 to Hubble's galactic revelations in the 1920s, each discovery chipped away at anthropocentric illusions, revealing Earth not as the throne of creation, but as a modest world orbiting an average star in a spiral arm of the Milky Way. This demotion, painful at first, fostered unity. The 1968 Earthrise photo, captured by Apollo 8 astronaut William Anders from 384,000 kilometers away, a blue marble rising over the lunar horizon, ignited the environmental movement, birthing Earth Day in 1970 and global accords like the Paris Agreement in 2015. The universe's scale, with its 2 trillion galaxies each brimming with billions of suns, underscored Earth's uniqueness, a haven of liquid water, diverse life, and conscious minds capable of pondering infinity. In reflection, this legacy teaches humility. Our 7,917-mile diameter planet, with its teeming oceans and towering peaks, is a rare jewel, worthy of protection against the cosmic indifference that could snuff it out with a stray asteroid or solar flare. Yet the inheritance runs deeper, into the realm of inspiration that fueled human creativity across eras. Ancient astronomers like Hypatia in 4th century Alexandria, who refined Ptolemaic models amid philosophical debates, embodied the quest's intellectual fire. Their spirit echoed in Renaissance polymaths and modern pioneers like Katherine Johnson, whose calculations propelled Apollo missions in the 1960s, defying racial and gender barriers. The universe's vastness sparked artistic masterpieces. Vincent van Gogh's Starry Night in 1889, swirling with turbulent skies, captured the emotional pull of the heavens, while Johannes Kepler's Harmonicas Mundi in 1619 sought musical harmony in planetary orbits. In literature, H.G. Wells's The War of the Worlds in 1898 imagined Martian invasions, probing fears of the unknown, just as contemporary works like Anne Leckie's Ancillary Justice in 2013 explore galactic empires with themes of identity and scale. Music, too, resonates with cosmic echoes. Gustav Holst's The Planets Suite in 1916 evoked Jupiter's grandeur and Neptune's mystery, mirroring the solar system's 5.9 billion kilometer breadth. This cultural tapestry, woven from the threads of discovery, endures as a testament to humanity's imaginative reach, turning cold distances into wellsprings of beauty and meaning. Philosophically, the legacy confronts us with existential truths, forcing reckonings that transcend science. Immanuel Kant, in his 1781 Critique of Pure Reason, marveled at the starry heavens above as a source of moral law, a sentiment amplified by modern cosmology. The Big Bang's 13.8 billion-year timeline, refined through cosmic microwave background studies by Kobe in 1989 and Planck in 2009, positions humanity as latecomers to a grand narrative, our 200,000-year history, a blink against eons. This temporal vastness evokes Carl Sagan's reflection in Pale Blue Dot in 1994. Earth as a moat suspended in a sunbeam, where all human triumphs and tragedies unfold. The multiverse theories, from Hugh Everett's Many Worlds interpretation in 1957 to André Linde's Eternal Inflation in 1983, suggest our reality as one bubble in an infinite foam, challenging notions of uniqueness. In reflection, this fosters a cosmic ethics, stewardship not just of Earth, but of knowledge itself, urging us to preserve observatories like Arecibo's echoes and Hubble's archives as sacred relics. The fall's lessons, etched in economic and cultural scars, offer cautionary wisdom for rebirth. The mid-21st century collapse, driven by diverted funds and waning interest, mirrors historical precedents. The Library of Alexandria's destruction around 48 BCE, which erased astronomical texts, stalling progress for centuries. Yet from such lows, revivals bloom. The Renaissance reclaimed Greek knowledge, just as the 2080s Nova Accord reignited collaboration. Today's private endeavors, like the Breakthrough Starshot initiative announced in 2016 to send probes to Alpha Centauri 4.37 light-years away, hint at resilient futures. Reflection reveals that crises prune excess, distilling pure curiosity. Amateur astronomers, using apps like Stellarium since 2001, democratize the stars, while citizen science projects like Zooniverse, launched in 2007, classify galaxies from home. Earth's interconnected web, now fortified by AI-driven predictions of cosmic threats, embodies adaptive legacy, deflecting asteroids like the 2022 DART mission's impact on Dimorphos, proving we can alter fates across millions of kilometers. Emotionally, the universe's scale stirs a profound connection, binding generations in shared awe. Parents pointing at the Milky Way's hazy band, visible from dark skies, recount tales of Galileo's 1610 revelations, passing the torch. Festivals like the International Dark Sky Week since 2003 celebrate unpolluted views, reminding us that light years measure not just distance, but the light of understanding. In personal reflection, astronauts like Mae Jemison, the first African-American woman in space in 1992, describe the overview effect, a cognitive shift from orbit, seeing Earth's borders dissolve, fostering peace. This legacy heals divisions. In a world fractured by strife, the cosmos unites, as when the International Space Station's crews from diverse nations collaborated since 1998, orbiting at 28,000 kilometers per hour. As we ponder the infinite, the true inheritance is hope, an unyielding belief that curiosity endures. Though empires fall, the human spirit rises, drawn to the stars like moths to flame. Earth, a speck in the grand design, harbors dreamers who will one day reach further, perhaps to exomoons or distant worlds. The universe, with its dark energies and hidden realms, invites us still, whispering secrets across the void. In this reflection, we find